Okay, good morning, ladies and gentlemen. Welcome to week 6, Thursday's lecture. This technically will be my last lecture giving to you guys. I'll still be doing tutorials. I'll probably give another lecture later on in the course. But next week, Mr. Van Westhuizen takes over giving lectures. Before class, I was asking the question about how many classes there are in practical 6. And a lot of you are assuming there's only 4. And that's not actually the case. There could potentially be 2 more, depends on how you look at the question. What is the point of classes, ladies and gentlemen? Let me ask you that. I'll give you those online a few minutes to think about it. What is the point of classes that we've been doing up until now? Modularity, correct. How did you form your base class? Not talking about interfaces. I don't expect you guys to do there's no expectations for an interface in practical 6. An interface is not a class. Be very careful with your terms. How did you form your base class? How did you know what goes into your base class? Common methods. Correct. Commonality, common attributes, common functionality. Things that connect. But ladies and gentlemen, whoever said there can only be one base class? I don't remember it was one of the essays or myself ever saying there can only be one base class. Insert shapes. You only can have one base class, yes. But there's never any mention or restriction on how many classes you can have, at least in VB. A lot of other languages are starting to limit the number of pair-based classes. I know you have maths tomorrow or computer science. Do you have any mainstream students online? Those are not doing the 4-year degree. Are you guys also writing maths on Saturday? Okay, so it's both mainstream and extended writing maths on Saturday. That is rough. Okay, I'm not going to expect you guys to suddenly change your practicals, but I want you to know you have a chance to look at your practical 4 again and see regarding the class structure. There's no limitation to saying there is only one base class. You could have a base class, then it has a second class, and that derived class has 2 child classes, and then you could have a base class, another class that inherits from the base, and then it also has a child class. You guys are too fixated on a single line, single level inheritance. There could be multi-tier inheritance. So you could have a situation like that even. We have common methods between 2 classes, but they're not common methods amongst all the classes. Okay, so you could have class A, B, C, F, and E. Oh, like calculate interest, yes. So you could technically have a situation where you have your main parent class, then it has a child class, and the child class has two classes that inherit from it, and another child class there, and it could actually inherit. There's nothing nothing wrong with this either. Okay, so just think about it for practical 6. I'm not saying go and change it because I know you guys are studying for comp sci and maths, but just think about it as you move forward in your work. Okay. Between yesterday and today, I was trying to figure out how to explain interfaces. So I did some Googling and whatnot to try and find another way to explain a interface class. Okay. So we're going to go back to my lovely diagram of half-done classes. An interface class, some websites refer to it as a a contract between objects to say certain things will be done. So I'm going to read some definitions. In object-oriented programming, an interface allows you to specify a set of functions and hide the implementations of those functions in implementing classes. Interfaces form a contract between classes and the outside world. Okay, so remember, you can't call it interface class. An interface class doesn't exist. There's an interface and a class. So a interface forms a contract between the class and the outside world. That's one way of looking at it. Another way allows a computer to enforce certain properties on a class. So interface can enforce certain methods or properties onto a specific object / class. So enforce a certain functionality. I'm just going through a whole bunch of different things here. Interface is a device or system that with unrelated entities used to interact. Okay, so unrelated entities used to interact. So let's have a look at this example here. Okay, I know you're all early morning. Is there any connection between a person and an account? Ladies and gentlemen, no. Person owns the account. Nah. Let's say a store account. No connection whatsoever. Being end of the month and everything, what is everyone getting? What is happening everywhere to everyone that's got a job? Especially being end of the month. Payday, yeah. Everyone's getting paid. Now, doesn't a person get paid and a store can't get paid? So interfaces allow us to connect things that don't really have a direct connection. So to make sure I don't make mistakes with the notation. Okay, so it is that. No, not that. Interface. A value as value amount. Thing that's integer, double. And this could be a void. So subroutine. But technically, we could connect person and store account to interface. Because they both have, they're both going to get paid. Void subroutine. I'm seeing the right attributes on this line. Arrow. Now, when a form implements, a class implements a interface, the UML diagram is a dotted line. Just keep that in mind. So here we have a person and a store account who normally have nothing in common. Yeah, void is used because a subroutine returns nothing. So it's a void. Subroutines are void. So here, a person and a store account will both have a function or subroutine called pay. They don't have anything else in common but pay. But what I'm doing is I'm forming a contract with classes saying you will implement pay. There will be a method called pay inside your setup because that's what I'm saying in the UML. Regardless if these two things have a connection between each other, they both have the method pay because I get paid, I have to pay store accounts. Store accounts have to get paid and people have to get paid. They have a common method in that, but nothing else. Does that kind of make sense for an interface, ladies and gentlemen? It's a list of to-do things that are generally things you have to implement. Okay, it's not an abstract in the sense that you can push it onto someone else. You have to implement them. And it is a interface. Will the interface be in the base class? No, not always. Interface could be a separate one. We'll look at an example in a few seconds now. Okay, not all interfaces are going to be a base. No, the interface isn't really a base class. It won't be even in the base class. It's an add-on to a base class, if you can say that. If that's actually the right way of saying it, I guess. It's an addition to the base class. So a class can have a base class and it can implement an interface. So let's look at the example in the slides. Okay, so we have that from yesterday. Then we have our abstract. Why I have to go from there? Well, hold on. The thing is, we don't inherit from an interface. We implement an interface. Okay, so is everyone okay on the base principle idea that an abstract class can have some functionality and is missing sometimes? An interface, however, is always missing. It has no functionality. Interface has absolutely no functionality ever. Okay, and then a concrete or complete class has all the functionality done. Okay, so here we are looking at the extending the Informatics 1A, because in Informatics 1A, if you get 70% or more, you get promoted, correct? Unfortunately, that doesn't apply to Informatics 1B. In Computer Science 1A, did you get promoted as well? Okay. So do all UJ modules have a promotion functionality? No. Okay. Only Pacific ones have a promotion functionality. So enters an interface. It also allows for a connection between things that have nothing in common, like I showed you, a store account and a person. things that have nothing in common, it creates a connection. Okay, it creates a list of requirements. You must be this tall to hit your head on the sign. Yeah. That's quite accurate for cyanide and happiness. Okay, so it's a list of requirements, a list of to-do things. So we had the example of all the vending machines. Now, all the vending machines do something in common, but they're a bit outdated in this case, because now vending machines use credit cards. So we add an interface on top of that. So we can take these and implement an interface for each one that gives them the functionality to use a credit card or a debit card or a check card, but use a card instead of just cash. So an interface, should actually take out the word class there. Notice something. Is it public or private interface? Do we indicate public or private here? Anywhere here, actually. Okay, this is VB code as well. This is not pseudocode. There's no mention of public or private because everything is public. Okay, everything within a interface is public. So we don't even say it's public. Are there any instance variables? No. There's a property method, but no instance variables. Okay, I'm a real boy. There's no functionality, ladies and gentlemen. This is a full interface. There's nothing more to it. Okay, so there's nothing else to an interface. There's simply, I need a property method and I need a subroutine. That's it. There's nothing more to a interface. That's all that goes with it. So you will go to a class and implement promotable, which will then invoke this. I'll do the code with you now. That invokes this by default. Notice, look at the naming of this. Public property sum variable as integer implements promotable dot sum variable. So this part here says that it's going to implement the function or the method or the attribute property from the interface. So that part says that it's implementing the interface's connection. Okay. Now, VB always has this throw new not implemented exception. This you guys would have seen a bit more often with practical 6 when you had a must override function or must override subroutine. This generally will throw an exception because you have got no code. So it's a way of saying do it later, but we must do it at some point. Okay. Where's my So here we have UJ Informatics 1A inheriting from UJ module. Okay. And it also is connected to interface. So its base class isn't the interface. Its base class is UJ module, but it connects to, it semi-inherits from promotable. What this means is an Informatics 1A it is a UJ module, but it is a promotable as well. It becomes both. It's not a base class, it's an addition. So it is something else as well. So an Informatics 1A is a UJ module, but it is also a promotable. So it has the promotion option as well. So other modules that would implement this would be Computer Science 1A. Informatics 100 would implement the promotable functionality because there are very few modules that have the promotion ability. So it's not something that every class would get. There's only certain classes would obtain this functionality. And those certain classes need to implement this functionality because they both are UJ module and they are promotable. So they need the extra functionality. Does that kind of make sense? So it's just a resource. It's more of a to-do list. Okay, it's more of a to-do list. Things you have to do. Because anything that implements the interface has to have some variable and check promotion. It has to have this functionality. A to-do list for certain classes only, yes. It is a to-do list for certain classes only. Only classes that need that promotable functionality will get this interface. Okay, and everyone else is still mulling it over, I guess. I'm actually implementing an interface with you now, so you guys can see what happens and see how to make it. Okay, but it's important to understand the fact that an interface we can inherit and we can implement as many interfaces as we want. There's no restriction on how many interfaces we implement. We can implement as many interfaces as we want. Lines 5 and 8 are AutoGen. Yeah. I'll show you those being AutoGen when I actually do it in a few seconds. Okay, let me actually, why is it AutoGen? Let me throw a curveball at you guys. A lot of you rely on the auto generation of code quite often. Those doing computer science know that not everything is auto-gen. No, not because of line 3. What auto-generates all this code for you? No, not inherits. What allows the auto-generation to occur? Let me test your knowledge of IT. Not Visual Basics either. Interface is its own type of programming. Mr. Oliver is the closest. Visual Basic has the functionality. Not Visual Basics, Visual Studio. Okay. Have you guys ever heard of an IDE? What is an IDE? It's an integrated development environment. Let me just double check. IDE is an integrated development environment, not independent. Okay. The reason code gets auto-generated for you is because we're using Visual Studios. Okay. A lot of you are relying on Visual Studios for support, which is not wrong. That's why we use Visual Studios. But does it mean the only way to program is through Visual Studios or through an IDE? While I'm getting to Visual Studios, let me just ask that question. Can you only program if you have an IDE? No. Okay. Just come on, Prom 101? No. How about text file, a notepad 101? I don't know if Mr. Mugganall still does it, but I know your first Java application used to be written in Notepad. Okay, so you guys rely on IDEs. Even I rely on IDE. I'm not saying it's just you. What I am trying to point out is the auto generation is something that is built into the IDE. Okay, so here if I go and right click on the name and I go add new item. Okay, now you'll notice there is class, which is by default the first one, modules and interface. So we can make an interface. So let's make interface promotion.bb. So we have a public interface promotion. No mention of the word class. Just going to make another class. Let's say UJ. Let's just go informatics. That already exists. Where the hell does that? How is that possible? Oh hell. Okay, that's fine. This helps. Regardless, it is, yeah. So is the UJ module, which is good. Okay, so there's our informatics 1A. If I go implements, okay, this is known as realization. I'm realizing an interface. Promotion. It's got no functionality, so let's add some function, or let's add some attributes. So it's got property. Um, I've got a function check promotion as boolean. So that's my interface, done. Nothing else. We don't write any other code, we do nothing else. We just simply have the name of the, we don't have must inherit, must override, we have nothing. We just have the name of what it is. So it's a property method, it's a function, it's a subroutine, just do a sub. This is the one place I wouldn't put an option in the option statements, because it's got nothing really to it. If you make mistakes here, then you have other problems in life as well. Then why do we need an interface for? To ensure certain functionality is done. It's a contract. It's a to-do list. So if I go here and implements promotion, is it called promotion? Why isn't it doing the code for me? I think this class is broken. That's why. Okay, let's make a new module. Let's make a computer science module quickly. Okay. I think something's gone wrong with connections on that class. So here we have our option statements. We can inherit. I don't know if UJ module still exists. No, UJ module, it's not really in the code, which is interesting. You can implement. I'll notice if I do that, the list of potential the interfaces is actually quite long. There are hundreds of different interfaces built inside Visual Studios for us to actually connect to. So just be careful of that. The general terminology for an interface is I and then the name. So you can make it a list, a grouping, a formatable. All of these are types of interfaces to invoke certain functionality. There's the one we made, iPromotion. Press enter and voila. The code is automatically generated for me. Okay, and that's thanks to the IDE. So IDE will go and generate all these connections for me and allow me to actually work with such code. But you notice it throws lots of not implemented exceptions. So you must actually go and complete the functionality for all of these. But again, I did not go and create these. These are automatically generated by Visual Studios because the simple fact that this class implements promotion means it has to go and do these functionality. It needs to provide these functions. Okay, it is a to-do list for a specific class. So as soon as you implement or realize an interface, this is interface realization. Okay, that's implementing. This is interface realization. So we are realizing the functionality of the interface, which has no implementation. It's 2 in the morning. So it allows us to say that the certain functionality has to be done within a class. And what happens is, and this will come into when you do polymorphism, is that this class is no longer just a computer science 1A class. This class is also a iPromotable. Okay, the mic's on. You can ask a question. Somebody's hand. Omar.
Oh, hello, sir. Can you hear me now?
Yeah, I can hear you.
Okay, yeah. So the question I have is that the difference between a base class and an interface class is that an interface class, unlike a base class, doesn't need to have elements that are common to all the other classes, but it can have like elements that are common to maybe 2 or 3 classes.
Correct.
Okay, thanks, sir.
Okay. So as I don't know how to pronounce your surname properly. I'll do an embarrassment on that one. As the gentleman just said, it's sections of code that not all your classes have common. So going back to the example, we have more than one UJ module, correct? Okay. I'll come back to your question, Omar. Now, do we have more than one UJ module based on the examples we've been doing? We have Informatics 1A, and what else did we have? Okay, we had maths. I don't think you guys want to talk about maths, but you had business management. Do maths and business management have the promotable functionality? And while I'm here, I'm annoyed by that. I'll update the slides to represent that as well. No. Okay. So only Informatics 1A will have promotable. I know we can just implement the functionality for promotable inside the class. We don't need the interface, but it forces certain functionality to come into existence. Okay. Oh, space limitations always. So what happens here is any class that implements this interface has to do these functionalities. It's not, okay, we can do it without it. It forces, remember, you're not always going to work, you don't always work on a project by yourself. So you can force another developer to do certain things. The Informatics 1B doesn't have promotions. And the name of the class interface always started with iPromotable. I'll go and fix that just now. It's a list of a way of forcing certain functionality into a module, into a module, into a class. So classes that have nothing in common are forced to have a common functionality, and that is quite important. Okay, because these classes can be referred to as promotable. It'll make a bit more sense in polymorphism as well. Okay, interfaces, how useful a class, an object-oriented programming, and inheritance really shines in polymorphism. Okay, so when you get there, you guys will have a better understanding of where you can use this and actually really benefit from a interface and from inheritance. Because right now, all you're seeing as inheritance is you are inheriting functionality. Polymorphism shows you the real benefit of all of this work we're doing. So once you get to polymorphism, hopefully it'll make a bit more sense in terms of where and why we do certain things, or why we're showing you certain things at least. Okay, I'll update the slides. Can a child class have a subroutine or function that is not connected to the parent class or other classes? Yes. A child class can have a subroutine that has no connection to the parent, yes. And remember, as you go down, go to the slides. As you go down these levels of inheritance, each class gets more specialized, gets more focused. So it's only natural that they have methods that don't exist in the parent or in the other one. Because why are they separated if they got everything in common? Okay, they have to have something that differs them, be it an extra method, be it a way of implementation. There must be something that makes the reason to have class C and class F. If there's no difference between the two, why do we have them? So there must be some difference between these two classes to justify them. Either extra method, different calculation. There must be something that is different. Okay, and that you must keep in mind, ladies and gentlemen. There has to be a change. It can't just be the same thing again and again and again. Else, what is the point? So as you move down inheritance, it gets more specific. The functionality is completed. Extra functionality can be added. Functionality can be changed. There must be something that actually justifies adding a class like this. If there's no reason to add a class just because you want to have the class, that doesn't justify it. Okay, you guys are misunderstanding. You don't have an object of the parent or child class. Once you instantiate an object of say type C, you have type C, but it is type B and A as well. Okay, so there's no instantiating part of A inside C. C is A and B, but you instantiate object C. I'm not sure what the question is. How to instantiate objects from parent? There is no objects in your parent class right now. There's no composition. Remember, you're inheriting functionality. So when you instantiate object C, or object B, or object F. You don't instantiate C, B, and A. C is B and C is A, yes, but it is C. It is class C. So if I create an object of type C, I have object C. So I'm not going to go and create objects A and B inside C. That's composition. Remember, composition and inheritance are different. Composition is a, inheritance has a. C does not have B. Going back to the examples here. In Informatics 1A, does Informatics 1A have a UJ module? Okay, no. Informatics 1A is a UJ module. It doesn't have a UJ module. Can inheritance and composition be together? Yes, it can. You can have composition and inheritance in the same code. Yes, that it can exist. But you got to remember that the classes are what they are. Because technically, a UJ module, this is kind of missing something. It depends on which approach you take it. It's also missing students. Or a student would be composed of UJ modules. Okay, so there is composition in that regard. That will come in later. Right now we're focusing on them individually. Later on we start to combine them. Okay, but don't get confused between composition and inheritance. They're two different things. There's no informatics UJ module in Informatics 1A. Informatics 1A is a UJ module. So it has semester mark, semester test 1, 2, and calculate exam mark here. It has this functionality built into it because it's inheriting. It doesn't have a UJ module. It is a UJ module. Okay, and I'm starting to run out of time as well. Okay, this afternoon's tutorial will be partly Q&A and partly focused on inheritance, I guess. The class will decide when you start the lecture of the tutorial this afternoon, but I think, let's keep the mouse across. There's no real announcements, just please make sure you do your practicals correctly. If you're going to upload them, make sure you upload in time. Remember, submission time is 8 o'clock now. And for those who I don't see before they write their semester test for computer science tomorrow, good luck for tomorrow. Don't stress out too much as you will forget your work. Okay, I got a question there. So for the practical, is it okay if we change the names of the methods given? For example, deposit refunds does the exact same thing as deposit, so I could so could we not use one inherited method for both? No, we're putting limitations on you. We've given you specific names for a reason. So if you change the names, we won't mark it as correct. Okay. And remember next week this time, what will you be doing? Before I finish the recording. What will you be doing this time next week? Yes. You'll be writing semester test 1 for informatics. Not relaxing. Not stressing either. Okay. Ladies and gentlemen, take my advice. I've got enough years of experience in studying and stressing and panicking. Stressing doesn't help with the test. Stressing during a test actually causes you to forget more than anything else. Actually triggers a psychological reaction or a physical reaction in your body to cause you to stop thinking properly. Okay, so stressing actually causes your mind to stop thinking on a logical approach and forces it into a more fight or flight reaction. So stressing actually makes it worse. So try and avoid stressing as much as possible, as all it does is makes you forget actually takes away your cognitive skills, if that makes sense. Can I add more parameters to the existing parameters in the constructor? No. You can't add more parameters. In the child class, you technically could. I don't see an issue with that. So why do we have cint in a class when we're using the my_base function? I don't exactly understand that question. Cint is converting into my.base. I don't know what is my. You have my_base dot something. That's something else together. So cint converts values to integer. My_base is calling the base class functionality. But getting back to stressing, try and avoid that as much as possible, ladies and gentlemen, as it actually takes your mind out of a cognitive thinking situation into a flight or fight reaction. So try and focus on what you do know. But informatics 1B is misbehaving now. Informatics 1B never misbehaves. The lecturers misbehave, but not the subject. Ladies and gentlemen, unfortunately, as you move up in the years, the speed in which you do your modules increases. The amount of information you have to handle each year does increase as well, so bear that in mind. Remember, ladies and gentlemen, you're trying to aim for a degree. So I'm not sure about the salary. You're aiming for a degree. It doesn't come without hard work. You don't just get a degree. A degree comes with hard work. Okay, hoping the salary is worth it one day. Yeah. I chose lecturing, so I don't know what the salary is like in industry. So can we add extra parameters in our child class for practical? Can we add additional functions? There's no reason to add additional functions, but you can, I guess. Just have to justify it. No, wait, you can't add extra I'm not sure what you mean by parameters. You guys are overthinking the practical, which is the problem. Okay, but time's up, so I'm going to stop the recording so that